think we have to accept that photovoltaics is really here to stay. To convert sunlight energy directly to electricity is by far the most efficient way to utilise the sun's energy. There's a lot of publicity around photovoltaics at the moment in the UK because of the government feed-in tariff subsidy scheme. But there's always a big question, especially in the UK, as to whether the weather can really deliver enough energy to be sensible and to be useful. So the emerging technologies that we're developing here in the physics department at the University of Sheffield are those based on plastic materials to absorb sunlight and then convert that sunlight to electricity. And the manufacturing methods for these types of devices are quite significantly different. So we'd be using basically coating methods developed in printing industries and in the thin film coatings industry. And we suspect that, well, we know that the embedded energy within these kind of devices is going to be substantially lower than that for a crystalline silicon technology. And in the future, that should make these emerging technologies lower cost to manufacture. And it's that progression that we need to learn about. But obviously there's a trade-off here, and the trade-off is that the ultimate efficiency of a plastic-based solar cell can never reach that of crystalline silicon. So we need to consider the economic arguments when really understanding where to deploy a plastic-based solar cell. So certainly solar cells based on plastic materials and organic materials are not the only emerging technologies. And in fact, there are many different technologies that have been around for many years. The solar farm has been set up to test and understand the performance and deployment of different technologies, different photovoltaic technologies in northerly latitude situations such as Sheffield in the UK. The University of Sheffield has always been very good at knowledge transfer and outreach and engaging with the wider publics and industry in terms of its research agenda. And in that sense, we can really use the resource, the wide-ranging resource of university academics to help understand about photovoltaics for the UK.
I'm Dr. Lisa Hall. I'm the Knowledge Transfer Fellow on the Sheffield Solar Farm. The role's quite varied. The general principle of the job is that I work in between the researchers at the university and then the full supply chain for the UK PV market. So that covers everyone between manufacturers through to design principles, installation, distribution, and then through to users, people who put PV onto their roofs and then generate the electricity for whatever purpose, whether that's domestic or commercial. From the point of the research, it's really good to know where these technologies are going to be used, where they're based, and who's going to use them for what purpose. So what we're asking users for is their own power readings from their installations on their roofs. So we're then being able to correlate the weather that we're getting across the UK from the Met Office with the generation that they're getting on their installations on their roof. So understanding exactly what their installation is like, the type of panels, the elevation, where they point, we can actually use some heavy mathematical algorithms to then look at their data and work out their real live performance right across the UK, but correlated to the weather that they were seeing in their location. This project certainly isn't a traditional academic research project. We've deliberately engaging directly with the full supply chain of photovoltaics in the UK, and the role that Lisa fulfills in terms of this is rather unique in a university setting, and that maybe is something different about the way that University of Sheffield is working in terms of knowledge transfer and interactions with the commercial sector. The uniqueness of the project that we've got here is that the data that we're collecting from these solar panels on test isn't just fed to the manufacturers as a direct collaboration, but it's also fed to everybody via a website where we show an online and live energy yield of all of the different technologies on test. So our dissemination is directly to anybody that's interested in the photovoltaic industry. So that could, as Lisa says, that could be the end user or the distributor or the manufacturer of the technology. And it's crucial to have an independent view. It's important that people see that this isn't a sales technique. This is actually how well the PV modules are doing in the real world, not just here in Sheffield, but also across the UK. And we can look at both the direct sunlight coming from the sun at any given point, but also the diffuse component of the sunlight. So that's everything that's reflected off the clouds and scattered irradiation from around us. Sadly today, it's mainly diffuse, so we've got one graph on the top, but what we can then do is look at the power generation from the panels. Now this is the graph coming from our main array, which are these 54 at the back over here, and we can see a direct correlation between the sunlight that we're getting and also the graph that we're getting from the power output per square metre. What we've also got is a list of all the different modules that we have installed on the test bed. So for example, we can look at individual modules, and then for each individual panel we can look at a photo of the module as it's installed at the farm, some information about the specifications of that panel as a user might see on a specification sheet, but also then the data, the live data from that panel as it is corresponding to the data from the sunlight that we're getting.